Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So in this video, I'm going to show how to analyze data using analysis of variance using Microsoft Excel. Right, ANOVA, or analysis of variance, the short form for analysis of variance is ANOVA. Basically, ANOVA is to compare the mean of more than two independent population. Remember on the last video, when you have two independent sample population, so we are going to use t-test, either unequal variance or equal variance. So when we have more than two independent sample or population, so we can use one-way ANOVA, right? We can use one-way ANOVA. So ANOVA is used to test the null and alternative hypothesis in the following way. So first, we need to state the null hypothesis mu1 equal to mu2 equal to mu3 until mu n. Means it depends on how many group do you have. So if you have three groups, so mu1 equal to mu2 and equal to mu3. If you have four groups, then it should be mu1 equal to mu2 equal to mu3 equal to mu4. It depends on how many groups you have. So the alternative hypothesis, not all population means are equal. At least one, or another way we can rewrite the alternative hypothesis is at least one mean is not equal, right? At least one differ is a rejection for null hypothesis. Right, so there is an assumption when you want to apply one-way ANOVA. First assumption is the distribution or the population should follow the normal distribution and has equal variance, and the population should be independent. So the second assumption is not really a tight assumption. There is a method to overcome equality of variance. If you have a non-equality of variance, you also can proceed with the one-way ANOVA. But the very strict assumption is the normality assumption. If the normality assumption for each group is not normal, then you cannot proceed with one-way ANOVA. You should go for non-parametric analysis such as a Kruskal-Wallis analysis, right? So in this section, we only discuss one-way ANOVA. So one-way ANOVA means that we have one variable or factor, right? Means that we only have one dependent variable, and one independent variable. Means independent variable, it should be either categorical variable, more than two group, right? More than two group means three or more, and dependent variable should be numerical, right? This is the assumption that, or the criteria or properties that suit with the one-way ANOVA. So the ANOVA test is used to determine the total variance, that the variance between sample and variance within the sample. So one-way ANOVA use F statistics instead of T or Z statistics. Use F statistics, where F statistics is a ratio between two variants. So variance between the sample divided by variance within the sample. So we can use in Excel, there is a data analysis tool such as analysis toolpack add-in to test one-way ANOVA, which is ANOVA single factor. Right, let's look at example number 6. So in this example, an analysis is done on the dividend yield for stock of three different subsector in a financial service sector listed in Bursa Malaysia. The analysts would like to know whether any subsector has different dividend yield from others. So we have insurance sector, banking and other financial, and each we have a data which is reflect the dividend yield, right? Dividends based on each sector. And if you can see here, we don't have an equal sample size, means that the least sample on insurance, then followed by banking and other financial. So we can look the data into stock dividend yield data set in Excel file, which is you can find it in a discussion section to download the data stock dividend yield. So I have already opened the stock dividend yield. So now if I want to know whether these three subsector are different or equal, right? So this is the objective. We want to know whether this subsector has a different dividend yield from others. So to start with, first we need to state our hypothesis statement. So our hypothesis statement, null hypothesis, will be mu1 equal to mu2 equal to mu3, because we only have three sector, which is mu1 should represent insurance, mu2 representing banking, and mu3 representing others financial. So alternative hypothesis, at least one mean dividend is not equal, right? And our alpha should be 0.05. And then the next step is test statistic. So this is the process, a step of doing hypothesis testing. In comparing more than two group, we are using F statistics, right? So to calculate F statistics, we just need to go for our data set and click on data tab and find data analysis. Find data analysis function. So this one you can download using data analysis data tool pack add in Excel. So to install this, I already explained in the previous video. So to calculate the difference of these three, so we're going to use ANOVA single factor. Just click on ANOVA single factor and click OK. So the input range would be you're selecting all the data from A4 until C15. So alright, and then since we are grouping the data by column, so insurance in one column, banking in another column, other financial is C column. So we are grouping the data by column, right? And then label in first row means that if you want to use label from first row, then we need to rearrange the input range, right? So means that we're going to select from A3 until C15, right? And we put label in first row, and then our alpha should be 0.05, and our output range means that we want Excel to display the result on this worksheet, right? So we put on E4, means that Excel will summarize the result here, and then we click OK. So now if you can see, Excel gives us two tables. First table is a summary table. Let me highlight this one, the summary table, right? And the second table is ANOVA table, right? So ANOVA table, if you can see on summary table first, in summary table they give us the basic descriptive statistics, which is how many observation are in insurance sector, how many observation in banking sector, and in other financial, the total value, average, and the variance. This is just as descriptive statistics. So we are now focusing on the second table, right? So in the second table we have between group and within group. The SS is representing sum of square, right? This is representing degree of freedom, and this is a mean. This is mean square, and this is the F statistic, and this is a p-value, and this is a F criteria. Let's look at the test statistic. We want to find the value of F. So the value of F will be 1.4497. Right. So next step is we're going to look into p-value. Right. Look at p-value. Our p-value here is 0.2529. So we state our p-value is 0.2529, right? So now our decision rule. Since we are using p-value measure, our decision rule would be if the p-value is less than 0.05, which is our alpha, then we will reject null hypothesis, right? So our decision, since p-value is larger than 0.05, which is our alpha, then we will accept null hypothesis. Means that it's a complement. If the p-value is less than 0.05, we will reject null hypothesis. If it is larger, we will accept a null hypothesis. It means that then we need to make a conclusion. Our conclusion says that the dividend, the mean dividend of 3 subsector are equal. Means we accept null hypothesis, means that we're saying that all the mean value are equal, right? Okay, I think that's all for one-way ANOVA. So I think that's all. Thank you very much. Assalamu alaikum.